Hello dear students, welcome to the lecture 4 of Software Engineering course. Today we are going to see requirements engineering. The topics covered today are
functional and non-functional requirements, the software requirements document, requirements specification, requirements engineering processes, requirements elicitation and analysis, requirements validation, requirements management.
Okay, so requirements engineering.
The process of establishing the services that the customer requires from a system and the constraints under which it operates and is developed. The requirements themselves are the descriptions of the system services and constraints that are generated during the requirements engineering process.
Okay, so there is a requirements engineering process which establishes the requirements of the system. So before we are starting to a big project, we actually for all projects we should have a requirements engineering process and determine what will be needed, what will be developed. This will just improve our software, it will make it better. So this is an important aspect of software engineering, software development. So
What is a requirement? It may range from a high-level abstract statement of a service or of a system constraint to a detailed mathematical functional specification.
so a requirement can be high-level abstract from a detailed mathematical functional specification. It can be anything, basically.
This is inevitable as requirements may serve a dual function. May be the basis for a bid for a contract, therefore must be open to interpretation, may be the basis for the contract itself, therefore must be defined in detail. Both these statements may be called requirements.
So you see, it may be a basis for a bid. Let's say you are going to develop a big software engineering project for a company, and that CEA of that company will check your project details. So he wouldn't likely to understand your detailed system descriptions. Why? Because detailed system descriptions would be in programming languages or programming languages related materials that will be in it. So an abstract would be more appropriate for the TAA of that company. However, when you are going to make the contract, it would be read by the engineers of that company or whatever the contractors. So it would be required to be in details, such as which methods will be used, which classes will be developed. You see, based on the job itself, requirements may be in details at coding level, or it can be abstract level as text. Okay.
Requirements abstraction, Davis. If a company wishes to let a contract for a large software development project, it must define its needs in a sufficiently abstract way that a solution is not pre-defined. The requirements must be written so that several contractors can bid for the contract, offering, perhaps, different ways of meeting the client organization's needs. Once a contract has been awarded, the contractor must write a system definition for the client in more detail so that the client understands and can validate what the software will do. Both of these documents may be called the requirements document for the system.
So types of requirement, user requirements. There are two types of requirements. First one, user requirements.
statements in natural language plus diagrams of the services the system provides and its operational constraints. Written for customers.
So what is natural language? By natural language, we mean that, let's say, talking in English or Turkish without using the programming languages or such. Okay, so this is natural language, and the diagrams are useful to demonstrate what will system do and such things. They are easy to interpret. And there is system requirements, and system requirements requires, of course, more details.
A structured document setting out detailed descriptions of the system's functions, services and operational constraints. Defines what should be implemented, so may be part of a contract between client and contractor.
Okay, so there is user and system requirements. User requirement definition, let's read it.
The MHCPMS shall generate monthly management reports showing the cost of drugs prescribed by each clinic during that month.
So what was the MHS PMS? It is Mental Health Care Patient Management System. Okay, so system requirements specification. Then first we make a user requirement definition. It is you see written in plain English that defines the requirements. And then there is system requirement specification, which will be used by the developers, engineers, and probably in the contract.
On the last working day of each month, a summary of the drugs prescribed, their cost, and the prescribing clinics shall be generated. 1.2 The system shall automatically generate the report for printing after 17.30 on the last working day of the month. 1.3 A report shall be created for each clinic and shall list the individual drug names, the total number of prescriptions, the number of doses prescribed, and the total cost of the prescribed drugs. 1.4 If drugs are available in different dose units, e.g., 10 mg, 20 mg, separate reports shall be created for each dose unit. 1.5 Access to all cost reports shall be restricted to authorized users listed on a management access control list.
So first, from user perspective, the requirement has been defined pretty simply. It says that we just want reports of that month's activity. You see, this is a plain English request. And then for engineers, for developers, there is a detailed specification which tells what will be the software do, what will the software do, and what will the output of the software, how will it behave. So details are provided. This way, engineers, the developers knows what to do. Okay.
Readers of different types of requirements specification.
So who reads the user requirements? Client managers reads them, system and users reads them, client engineers reads them, contractor managers reads them, and system architects reads them. You see, almost everyone is reading user requirements. So it is written in natural language and it is written in as an abstract. So system requirements, who reads them? System and users reads them, and client engineers reads them, system architects reads them, and software developers reads them. So there's a key comparison between these two. Software developers read system requirements because that is what is important for software developers. Okay, also contractor managers doesn't read the system requirements, as you can see, because they care about uh, whether the let's say the bidder can satisfy their requirements or not, and such. Okay, so there is two type of requirements.
Functional and non-functional requirements.
So functional requirements, what are they?
Statements of services the system should provide, how the system should react to particular inputs and how the system should behave in particular situations. May state what the system should not do.
So this is a functional requirement. You see, it defines when something is taken, what will be the output. It is like a method or a function in programming languages. So non-functional requirements.
Constraints on the services or functions offered by the system such as timing constraints, constraints on the development process, standards, etc. often apply to the system as a whole rather than individual features or services.
You see, there is not a method or function in these non-functional requirements. It doesn't say when this happens, output will be this. No, it says it should work like this or behave in these constraints and such. So there is also domain requirements.
Constraints on the system from the domain of operation.
So what does domain mean in this sense? Domains means the area that you are going to work. But it can be, let's say you are going to make medical healthcare system. So the domain is medical healthcare in that case, or let's say you are going to develop a library software. So the domain is being libraries. So domain is the area of what you are going to program. Okay. So functional requirements.
Describe functionality or system services. Depend on the type of software, expected users and the type of system where the software is used. Functional user requirements may be high-level statements of what the system should do. Functional system requirements should describe the system services in detail.
Okay, so functional requirements for the mental health care patient management system.
Functional requirements for the MHCPMS. A user shall be able to search the appointments lists for all clinics. The system shall generate each day, for each clinic, a list of patients who are expected to attend appointments that day. Each staff member using the system shall be uniquely identified by his or her 8-digit employee number. Requirements imprecision. Problems arise when requirements are not precisely stated. Ambiguous requirements may be interpreted in different ways by developers and users.
So the requirements should be precise. They shouldn't be vague. Okay, if your requirement is not clear, it can be interpreted differently than its intended meaning from both users and developers, and it can cause a lot of problems.
Consider the term search in requirement 1. User intention, search for a patient name across all appointments in all clinics. Developer interpretation, search for a patient name in an individual clinic. User chooses clinic then search.
So you see, there is two interpretation of the search. User want to search for a patient name across all appointments in all clinics, so it covers more area of search. It is harder to do also. It requires more CPU power and system power, and developer interpret it as search for a patient name in an individual clinic. So developer expect a clinic ID in the search because it expect user to choose clinic. So these are this difference may be caused by the imprecise requirement definition.
requirements completeness and consistency. In principle, requirements should be both complete and consistent.
So complete, as a complete requirement.
They should include descriptions of all facilities required.
So consistent.
Consistent. There should be no conflicts or contradictions in the descriptions of the system facilities. In practice, it is impossible to produce a complete and consistent requirements document.
Okay, so there is also non-functional requirements. What are they?
These define system properties and constraints, e.g., reliability, response time, and storage requirements. Constraints are I/O device capability, system representations, etc. Process requirements may also be specified mandating a particular IDE, programming language or development method. Non-functional requirements may be more critical than functional requirements. If these are not met, the system may be useless.
For example, let's say your software will run on a Linux system and you are going to develop your system with using Windows libraries. In that case, your software would not run on a Linux system, and that would make basically your software uh, unworkable. So non-functional requirements can be extremely critical. Let's say you want your engineers to develop the software in C++ because it will run on a embedded device, and the developer develops it with, let's say, Python, or Python may work on embedded device, but I'm not sure of any language that will not work on that particular device. So the software will be useless basically. So non-functional requirements can be extremely critical and important. Okay. So there is non-functional requirements. Let me read them. And then it is branched as product requirements, organizational requirements, and external requirements. And product requirements branched as usability requirements, efficiency requirements, dependability requirements, security requirements, and efficiency requirements are branched as performance requirements, space requirements. Then organizational requirements branched as environmental, environmental, environmental requirements, and operational requirements and development requirements. Then external requirements branched as regulatory requirements, ethical requirements, and legislative requirements. Then legislative requirements branched as accounting requirements and safety security requirements. So you see the type of non-functional requirements are so many. It is not a simple thing, and every one of these are important, and some of them can be more important for certain tasks. For example, safety security requirements would be very critical for high critical systems such as health care devices, let's say MRI scan or laser operations, and regulatory requirements can be very important for, let's say, software that are used by ISPs, and security requirements probably would be important for everything. So these are really important aspects of software engineering.
Non-functional requirements implementation. Non-functional requirements may affect the overall architecture of a system rather than the individual components. For example, to ensure that performance requirements are met, you may have to organize the system to minimize communications between components. A single non-functional requirement, such as a security requirement, may generate a number of related functional requirements that define system services that are required. It may also generate requirements that restrict existing requirements. Non-functional classifications. Product requirements. Requirements which specify that the delivered product must behave in a particular way, e.g., execution speed, reliability, etc. Organizational requirements. Requirements which are a consequence of organizational policies and procedures, e.g., process standards used, implementation requirements, etc. External requirements. Requirements which arise from factors which are external to the system and its development process, e.g., interoperability requirements, legislative requirements, etc. Examples of non-functional requirements in the MHC-PMS.
So let's see some example of non-functional requirements in mental health care patient management system. So the product requirement, as a product requirement,
The MHC-PMS shall be available to all clinics during normal working hours, Monday to Friday, 0830-17.30. Downtime within normal working hours shall not exceed 5 seconds in any one day.
okay, so as you can see, this system requires to be online and active all the time during the work hours. So to ensure that, you have to have a very, let's say, detailed planning of when to do maintenance and what to do when an error happens to keep the system online and working all the time. So this is a very strict requirement, product requirement, and then let's see an organizational requirement.
Users of the MHC-PMS system shall authenticate themselves using their health authority identity card.
And an external requirement example.
External requirement. The system shall implement patient privacy provisions as set out in HSTAN 03-2006 Priv.
So this looks like a government requirement. Let's check it out on the Google. Okay, I think it is here. Yes, you see National Defense Research Institute. And when I search for the keyword, oh, it isn't here, or maybe we couldn't search it. Anyway, it looks like a government requirement, a government protocol or something. And
Goals and requirements. Non-functional requirements may be very difficult to state precisely, and imprecise requirements may be difficult to verify.
so what's the goal?
A general intention of the user, such as ease of use.
So there, and what is a verifiable non-functional requirement?
A statement using some measure that can be objectively tested. Goals are helpful to developers as they convey the intentions of the system users.
So goals are very helpful for developers. Why? Because by achieving goals, they can also satisfy the intentions of the system users. Okay, or they can provide the necessary tools for the system users. And
Usability requirements. The system should be easy to use by medical staff and should be organized in such a way that user errors are minimized. Goal.
so this is a goal. It should be easy to use and it should be organized in a way that user cannot make mistakes, errors, even if they wanted.
Medical staff shall be able to use all the system functions after 4 hours of training. After this training, the average number of errors made by experienced users shall not exceed 2 per hour of system use. Testable non-functional requirement.
So this is testable. Why? By providing 4 hours of training, then you can make let's say poll for the people who took the training and ask them whether they have learned the system sufficiently or not. So we can test whether 4 hours of training was enough or not. Then we can collect the data of users and then evaluate them and check whether average number of errors made by the experienced users was over 2 per hour of system use or not. And so this is another testable non-functional requirement. So this is a good example of testable non-functional requirement, and this is a good example of goal.
Metrics for specifying non-functional requirements.
So we can have metrics to specify non-functional requirements so that we can check and evaluate how well we are doing. So speed metric can be measured by
Process transactions per second user event response time screen refresh time.
so this is how we can measure the speed by processed transactions second. This can be measured by the developers. User event response time. Again, this can be measured by the developers with just adding some statistics and counters, and then screen refresh time. All these can be objectively tested and logged to check. And size is even easier. Number of megabytes the system uses or number of ROM chips the system uses. Ease of use. This can be also measured by training time and number of health claims. And reliability can be measured by mean time to failure and probability of unavailability, rate of failure occurrence and availability. Then robustness can be measured by time to restart after failure, percentage of events causing failure, probability of data corruption on failure. And portability can be measured by percentage of target dependent statements, number of target state systems. Okay. So you see, for each property, there can be certain measurement types, measurement ways.
Domain requirements. The system's operational domain imposes requirements on the system. For example, a train control system has to take into account the braking characteristics in different weather conditions.
A train control system, of course, will control the plan and times of trains. So it should take into account the weather conditions, because some weather conditions may be inappropriate for the trains to move under them and such things. Actually, a plane control system probably a better example for this. I think I will make it even sky system, perhaps. And then it should be, I'm going to make this as okay. This is a better example.
Domain requirements be new functional requirements, constraints on existing requirements or define specific computations. If domain requirements are not satisfied, the system may be unworkable.
Okay, so train protection system.
This is a domain requirement for a train protection system. The deceleration of the train shall be computed as d train equals d control plus d gradient, where d gradient is 9.81 milliseconds 2 asterisk compensated gradient alpha, and where the values of 9.81 milliseconds 2 alpha are known for different types of train. It is difficult for a non-specialist to understand the implications of this and how it interacts with other requirements.
So for domain requirements, a specialist of that domain is mandatory. Otherwise, the software engineer will probably fail to understand the domain specifics and uh, develop software in the proper way, in the necessary way. So a specialist for each domain is extremely important.
Domain requirements problems. Understandability. Requirements are expressed in the language of the application domain. This is often not understood by software engineers developing the system. Implicitness. Domain specialists understand the area so well that they do not think of making the domain requirements explicit.
Okay, so key points of chapter 1.
Requirements for a software system set out what the system should do and define constraints on its operation and implementation. Functional requirements are statements of the services that the system must provide or are descriptions of how some computations must be carried out. Non-functional requirements often constrain the system being developed and the development process being used. They often relate to the emergent properties of the system and therefore apply to the system as a whole.
Okay, so let's go to part 2, chapter 2.
The Software Requirements Document.
So we are going to have a software requirements document, and this document will.
The Software Requirements Document is the official statement of what is required of the system developers. Should include both a definition of user requirements and a specification of the system requirements. It is not a design document. As far as possible, it should set out what the system should do rather than how it should do it.
So this is important. It should set what the system should do rather than how it should do it. So here we define what is expected from the system, what behavior is expected from the system, how should it behave, and such. But it is not about how should the system do it. How should the system do it is another thing, and how should it behave or what is expected from the system is another thing.
Agile methods and requirements. Many Agile methods argue that producing a requirements document is a waste of time as requirements change so quickly. The document is therefore always out of date. Methods such as XP use incremental requirements engineering and express requirements as user stories, discussed in Lecture 3. This is practical for business systems but problematic for systems that require a lot of pre-delivery analysis, e.g. critical systems or systems developed by several teams.
So it all depends on what system you are going to develop. If your system is non-critical system and can have bugs in the system, let's say it wouldn't cause monetary loss or health health problems, you may use agile methods and don't have requirements documents. However, let's say you are going to develop a nuclear plant software which can literally kill millions of people. You can't just use agile methods. It has to be planned and tested at every step of the software. Okay.
Users of a requirements document.
Okay. System customers.
Specify the requirements and read them to check that they meet their needs. Customers specify changes to the requirements.
And managers.
Use the requirements document to plan a bid for the system and to plan the system development process.
System engineers.
Use the requirements to understand what system is to be developed.
System test engineers.
Use the requirements to develop validation tests for the system.
System maintenance engineers.
Use the requirements to understand the system and the relationships between its parts.
So you see, requirements means something for something different for everyone. I mean, for every specific class of persons, requirements may mean something different. Okay. So for system customers, it means something. For the managers, it means something else, and for system engineers, it means something else. So the requirements is really important and changes according to who is going to read the requirements.
Requirements document variability. Information in requirements document depends on type of system and the approach to development used. Systems developed incrementally will, typically, have less detail in the requirements document. Requirements document standards have been designed, e.g. IEEE standard. These are mostly applicable to the requirements for large systems engineering projects.
Okay, so there is a 39 pages document. As you can see, you see they have documented how should the requirements be. Okay, in overview, let's read it.
Overview. This recommended practice describes recommended approaches for the specification of software requirements. It is divided into 5 clauses. Clause 1 explains the scope of this recommended practice. Clause 2 lists the references made to other standards. Clause 3 provides definitions of specific terms used. Clause 4 provides background information for writing a good SRS. Clause 5 discusses each of the essential parts of an SRS. This recommended practice also has two annexes, one which provides alternate format templates, and one which provides guidelines for compliance with IEEE EIA 12207.1-1997.
Okay, so if you wonder what are they, you can read it. Okay, so the structure of a requirements document. There is preface. Okay, so let's read the description of the preface.
This should define the expected readership of the document and describe its version history, including a rationale for the creation of a new version and a summary of the changes made in each version.
There is introduction, and let's read the description.
This should describe the need for the system. It should briefly describe the system's functions and explain how it will work with other systems. It should also describe how the system fits into the overall business or strategic objectives of the organization commissioning the software.
Okay, there is glossary.
This should define the technical terms used in the document. You should not make assumptions about the experience or expertise of the reader.
Okay, this is important. You should not make assumptions about the experience or expertise of the reader. So you assume that there will be people who is reading this requirements document without having any prior knowledge. Okay. And user requirements definition is described as.
Here, you describe the services provided for the user. The non-functional system requirements should also be described in this section. This description may use natural language, diagrams, or other notations that are understandable to customers. Product and process standards that must be followed should be specified.
Okay, I want to get your attention to something, diagrams. Diagrams are mentioned a lot because diagrams are extremely useful to explain things in a systematic way to everyone, whether that reader has previous knowledge or not, because we like to see, as a humans, we like to see visualized images of problems, concepts, and explanations and information because it is easier to understand, it is easier to memorize. So diagrams is a great way to explain things. System architecture.
This lecture should present a high-level overview of the anticipated system architecture, showing the distribution of functions across system modules. Architectural components that are reused should be highlighted.
Okay, I see I have written a lecture, but it is a chapter actually. Okay, I will fix it. Okay. Okay, let's continue. And system requirement specification.
This should describe the functional and non-functional requirements in more detail. If necessary, further detail may also be added to the non-functional requirements. Interfaces to other systems may be defined.
Okay, system requirement specification. System models.
This might include graphical system models showing the relationships between the system components and the system and its environment. Examples of possible models are object models, data flow models, or semantic data models.
Let's look for them. Object model. Okay, use the object model diagram here. UML. We will have more ideas about them in the future lessons. System evaluation.
This should describe the fundamental assumptions on which the system is based, and any anticipated changes due to hardware evolution, changing user needs, and so on. This section is useful for system designers as it may help them avoid design decisions that would constrain likely future changes to the system.
And appendices.
These should provide detailed, specific information that is related to the application being developed, for example, hardware and database descriptions. Hardware requirements define the minimal and optimal configurations for the system. Database requirements define the logical organization of the data used by the system and the relationships between data.
And index.
Several indexes to the document may be included. As well as a normal alphabetic index, there may be an index of diagrams, an index of functions, and so on.
Okay, requirement specification.
The process of writing the user and system requirements in a requirements document. User requirements have to be understandable by end users and customers who do not have a technical background. System requirements are more detailed requirements and may include more technical information.
So you should be careful when preparing user requirements because it has to be understandable by everyone, not just by software developers or engineers.
The requirements may be part of a contract for the system development. It is therefore important that these are as complete as possible.
Why it is important to them to be complete? Because if you provide an incomplete system requirements document to the developer would finish the product project in that way, and your system would be incomplete. Even when you try to fix the system later, it may even cause whole system to collapse or become useless. So system requirements to provide developers are extremely important. From developers' perspective, it is still important because you can make your software development plan according to the system requirements document and such.
Ways of writing a system requirement specification.
So how many ways we can use to write a system requirement specification? Natural language, obviously.
The requirements are written using numbered sentences in natural language. Each sentence should express one requirement.
And then we can use structured natural language.
The requirements are written in natural language on a standard form or template. Each field provides information about an aspect of the requirement.
And design description languages.
This approach uses a language like a programming language, but with more abstract features to specify the requirements by defining an operational model of the system. This approach is now rarely used, although it can be useful for interface specification.
Okay, graphical notations.
Graphical models, supplemented by text annotations, are used to define the functional requirements for the system. UML use case and sequence diagrams are commonly used.
And this is a commonly used way. And then mathematical specifications.
These notations are based on mathematical concepts such as finite state machines or sets. Although these unambiguous specifications can reduce the ambiguity in a requirements document, most customers don't understand a formal specification. They cannot check that it represents what they want and are reluctant to accept it as a system contract.
So if you provide mathematical specifications, more likely your contractors wouldn't understand it. Okay, so it is not an efficient, a good way of make system requirement specification in general. Okay, it is harder to understand, and they are, and customers may not spend time to understand them. Okay, so best way is using graphical notations. You see again diagrams and uh, such things, graphical models. Okay, so requirements and design.
In principle, requirements should state what the system should do and the design should describe how it does this. In practice, requirements and design are inseparable. A system architecture may be designed to structure the requirements. The system may interoperate with other systems that generate design requirements. The use of a specific architecture to satisfy non-functional requirements may be a domain requirement. This may be the consequence of a regulatory requirement.
Okay, natural language specification.
Requirements are written as natural language sentences supplemented by diagrams and tables. Used for writing requirements because it is expressive, intuitive, and universal. This means that the requirements can be understood by users and customers. Guidelines for writing requirements. Invent a standard format and use it for all requirements. Use language in a consistent way. Use shall for mandatory requirements, should for desirable requirements. Use text highlighting to identify key parts of the requirement. Avoid the use of computer jargon. Include an explanation, rationale, of why a requirement is necessary.
Okay, this is important. You should include an explanation why requirement is necessary so that your customer or users can understand it easier, better. So what problems?
Problems with natural language.
Okay, lack of clarity.
Precision is difficult without making the document difficult to read. Requirements confusion. Functional and non-functional requirements tend to be mixed up. Requirements amalgamation. Several different requirements may be expressed together.
So let's see example requirements for the insulin pump software system. We have seen the insulin pump in the previous lectures. Insulin pump is a critical system because it may literally kill your patients or cause permanent harm, damage.
3.2 The system shall measure the blood sugar and deliver insulin, if required, every 10 minutes. Changes in blood sugar are relatively slow, so more frequent measurement is unnecessary. Less frequent measurement could lead to unnecessarily high sugar levels. 3.6 The system shall run a self-test routine every minute with the conditions to be tested and the associated actions defined in Table 1. A self-test routine can discover hardware and software problems and alert the user to the fact the normal operation may be impossible.
You see, both are important because this is a health critical system. Therefore, it should have requirements precisely and in details defined. Okay.
Structured specifications. An approach to writing requirements where the freedom of the requirements writer is limited and requirements are written in a standard way. This works well for some types of requirements, e.g. requirements for embedded control system, but is sometimes too rigid for writing business system requirements.
Okay. Form-based specifications.
Form-based specifications. Definition of the function or entity. Description of inputs and where they come from. Description of outputs and where they go to. Information about the information needed for the computation and other entities used. Description of the action to be taken. Pre- and post conditions, if appropriate. The side effects, if any, of the function. A structured specification of a requirement for an insulin pump.
Okay, this is important.
Insulin Pump Control Software, SRS 3.3.2.
So this is probably the version. So function description.
Compute insulin dose, safe sugar level.
Actually, this is the function itself. So what does function does is compute insulin dose and safe sugar levels. So it computes insulin dose that will keep the sugar level safe. So the description of the function, this is the function, let's say, duty of the function computing insulin dose. And let's see the description of the function.
Computes the dose of insulin to be delivered when the current measured sugar level is in the safe zone between 3 and 7 units.
So what inputs the function takes? The inputs of the function.
Current sugar reading, R2, the previous two readings, R0 and R1.
So what is the source of the, let's say, inputs? Probably.
Current sugar reading from sensor. Other readings from memory.
So what is the outputs of the function?
Comp dose, the dose in insulin to be delivered.
So where is the destination of the function output?
Main control loop.
So what is the action of the function result?
Comp dose is 0 if the sugar level is stable or falling, or if the level is increasing but the rate of increase is decreasing. If the level is increasing and the rate of increase is increasing, then comp dose is computed by dividing the difference between the current sugar level and the previous level by 4 and rounding the result. If the result is rounded to 0, then comp dose is set to the minimum dose that can be delivered.
Actually, this is the definition of the function logic. Okay, so action is the logic of the function, we can say, I think. So the requirement of the function call.
Two previous readings so that the rate of change of sugar level can be computed.
So precondition of the function.
The insulin reservoir contains at least the maximum allowed single dose of insulin.
So the post condition of the function.
R0 is replaced by R1, then R1 is replaced by R2.
And side effects none. So you see, this is well structured because it uses a model. What model? It says the function and the mini description of the function, or maybe its name. Description of the function, the inputs of the function, the source of the inputs, outputs of the function, the destination of the function, the action logic of the function, requirements of the function, precondition of the function, and post-condition of the function, and the side effects. With this structure, you can pretty much formalize the every function, so it They would be described in a formal way, in a structured way, and this is what structured requirements mean. Okay. So a structured specification of requirement for an insulin pump.
A structured specification of a requirement for an insulin pump.
So here we are defining the logic of the function. It should be if the sugar level is falling, R2 is smaller than R1, comp dose is 0. If the comp dose is 0, it gives the minimum predefined amount of the insulin. Sugar level is stable, R2 equal R1, so comp dose is again 0. If the sugar level is increasing and the rate of increase is decreasing, what does that mean? That means that R2 minus R1 is smaller than R1 minus R0. Comp dose is again 0. And if the sugar level is increasing and the rate of increase stable or increasing, that which means if R2 minus R1 is bigger or equal than R1 minus R0, compound is equal to round R2 minus R1 divided by 4, and if rounded result is 0, then comp dose is minimum dose. So you see this logic defines every possible case and what action will be taken if that condition is satisfied. So if you provide this kind of structured requirements to the developer, to the software engineers, making mistakes is almost impossible, and it would make the job of the software engineer much easier. So let's say you are the manager software engineer in a development team, and if you prepare or ensure the requirements document is prepared this way, you can almost ensure success of your development. Okay, you can ensure the quality of development.
Tabular specification. Used to supplement natural language. Particularly useful when you have to define a number of possible alternative courses of action. For example, the insulin pump systems bases its computations on the rate of change of blood sugar level, and the tabular specification explains how to calculate the insulin requirement for different scenarios.
The tabular specification of computation for an insulin pump.
Tabular specification of computation for an insulin pump.
Basically, this is conditions and actions put in a table. Okay, it is easier to read, it is structured, and so
Requirements engineering processes. The processes used for RE vary widely depending on the application domain, the people involved, and the organization developing the requirements.
our A is requirements engineering. As you can see, it depends on the application domain, if it is a health critical system, or let's say if it's a very big system that requires multiple teams and so on. It changes, or the people involved, if everyone is expert of area, it would be different. If everyone is amateur of the domain, it would be different. And the organization that is developing, so you have to take into consideration everything.
However, there are a number of generic activities common to all processes. Requirements elicitation, requirements analysis, requirements validation, requirements management. In practice, RE is an iterative activity in which these processes are interleaved. A spiral view of the requirements engineering process.
So it starts business requirement specification, feasibility study, user requirements elicitation, user requirements specification, prototyping, system requirements elicitation, system requirements specification and modeling, reviews, and then system requirements documentation. However, there can be multiple loops of this to improve and such. Okay.
Requirements elicitation and analysis. Sometimes called requirements elicitation or requirements discovery, involves technical staff working with customers to find out about the application domain, the services that the system should provide, and the system's operational constraints. May involve end users, managers, engineers involved in maintenance, domain experts, trade unions, etc. These are called stakeholders. Problems of requirements analysis. Stakeholders don't know what they really want. Stakeholders express requirements in their own terms. Different stakeholders may have conflicting requirements. Organizational and political factors may influence the system requirements. The requirements change during the analysis process. New stakeholders may emerge and the business environment may change. Requirements elicitation and analysis. Software engineers work with a range of system stakeholders to find out about the application domain, the services that the system should provide, the required system performance, hardware constraints, other systems, etc. Stages include requirements discovery, requirements classification and organization, requirements prioritization and negotiation, requirements specification.
You see requirements prioritization and negotiation. It may be impossible to make all the requirements, or let's say you may dump some ideas, so it both includes negotiation and prioritization. Okay, with the stakeholders.
The requirements elicitation and analysis process.
Elicitation is also called as discovery sometimes. So requirements discovery is being done at the first stage, then requirements classification and organization is done at the second stage after we discovered them. Then the requirements prioritization and negotiation is done, and finally requirement specification is done, and after that we continue to find out if there are more requirements. So this is a interleaved, and perhaps we can say this is a iterative process. You may not discover all the requirements at once, and it may require several iterations.
Process activities. Requirements discovery. Interacting with stakeholders to discover their requirements. Domain requirements are also discovered at this stage. Requirements classification and organization. Groups related requirements and organizes them into coherent clusters. Prioritization and negotiation. Prioritizing requirements and resolving requirements conflicts. Requirements specification. Requirements are documented and input into the next round of the spiral.
So you see each stage is explained in details.
Problems of requirements elicitation. Stakeholders don't know what they really want. Stakeholders express requirements in their own terms. Different stakeholders may have conflicting requirements. Organizational and political factors may influence the system requirements. The requirements change during the analysis process. New stakeholders may emerge and the business environment change.
So the key points of chapter 2 are:
the software requirements document is an agreed statement of the system requirements. It should be organized so that both system customers and software developers can use it. The requirements engineering process is an iterative process including requirements elicitation, specification and validation. Requirements elicitation and analysis is an iterative process that can be represented as a spiral of activities: requirements discovery, requirements classification and organization, requirements negotiation and requirements documentation.
requirements is really important because let's say you are the head engineer of a company and you want to hire a team of developers to construct a software for your company, and if you don't prepare requirements properly, your final product may be useless for you and you couldn't claim uh, that the team didn't do their work because you didn't provide them the proper requirements. And without proper requirements, you cannot be sure that the work is done in the proper way. You cannot be sure the delivered software is uh, like as uh, claim it or like as you want it to be. Okay. So part 3, requirements engineering.
Requirements discovery. The process of gathering information about the required and existing systems and distilling the user and system requirements from this information. Interaction is with system stakeholders from managers to external regulators. Systems normally have a range of stakeholders.
Okay. Okay.
Stakeholders in the MHCPMS. Patients whose information is recorded in the system, doctors who are responsible for assessing and treating patients, nurses who coordinate the consultations with doctors and administer some treatments, medical receptionists who manage patients' appointments, IT staff who are responsible for installing and maintaining the system.
So you see there are many stakeholders in the uh, mental health care patient management system, and there are even more.
A medical ethics manager who must ensure that the system meets current ethical guidelines for patient care. Health care managers who obtain management information from the system, medical records staff who are responsible for ensuring that system information can be maintained and preserved, and that record-keeping procedures have been properly implemented. Interviewing. Formal or informal interviews with stakeholders are part of most RE processes. Types of interview. Closed interviews based on predetermined list of questions. Open interviews where various issues are explored with stakeholders. Effective interviewing. Be open-minded, avoid preconceived ideas about the requirements and are willing to listen to stakeholders. Prompt the interviewee to get discussions going using a springboard question, a requirements proposal, or by working together on a prototype system. Interviews in practice. Normally a mix of closed and open-ended interviewing. Interviews are good for getting an overall understanding of what stakeholders do and how they might interact with the system. Interviews are not good for understanding domain requirements. Requirements engineers cannot understand specific domain terminology. Some domain knowledge is so familiar that people find it hard to articulate or think that it isn't worth articulating.
So scenarios.
Scenarios are real-life examples of how a system can be used. They should include a description of the starting situation, a description of the normal flow of events, a description of what can go wrong, information about other concurrent activities, a description of the state when the scenario finishes. Scenario for collecting medical history in MHCPMS. Initial assumption, the patient. Initial assumption, the patient has seen a medical receptionist who has created a record in the system and collected the patient's personal information, name, address, age, etc. A nurse is logged on to the system and is collecting medical history. Normal, the nurse searches for the patient by family name. If there is more than one patient with the same surname, the given name, first name in English, and date of birth are used to identify the patient. The nurse chooses the menu option to add medical history. The nurse then follows a series of prompts from the system to enter information about consultations elsewhere on mental health problems, free text input, existing medical conditions. Nurse selects conditions from menu, medication currently taken, selected from menu, allergies, free text, and home life form. What can go wrong? The patient's record does not exist or cannot be found. The nurse should create a new record and record personal information. Patient conditions or medication are not entered in the menu. The nurse should choose the Other option and enter free text describing the condition, medication. Patient cannot, will not provide information on medical history. The nurse should enter free text recording the patient's inability, unwillingness to provide information. The system should print the standard exclusion form stating that the lack of information may mean that treatment will be limited or delayed. This should be signed and handed to the patient. Other activities, record may be consulted but not edited by other staff while information is being entered. System state on completion, user is logged on. The patient record including medical history is entered in the database. A record is added to the system log showing the start and end time of the session and the nurse involved.
Okay, as you can see, the scenario for collecting medical history is extremely detailedly explained. Every case is explained, how the regular flow will happen, explain it. This makes the job of engineers much easier, or this makes the stakeholders to understand how will the software work, software flow, how will it be. So use cases.
Use cases are a scenario-based technique in the UML which identify the actors in an interaction and which describe the interaction itself. A set of use cases should describe all possible interactions with the system. High-level graphical model supplemented by more detailed tabular description. See Lecture 5. Sequence diagrams may be used to add detail to use cases by showing the sequence of event processing in the system.
So what is UML? If you wonder, it is, let's open the Wikipedia English. It is Unified Modeling Language, and it is used a lot in software engineering.
The Unified Modeling Language (UML) is a general-purpose, developmental, modeling language in the field of software engineering that is intended to provide a standard way to visualize the design of a system. 1. The creation of UML was originally motivated by the desire to standardize the disparate notational systems and approaches to software design. It was developed by Grady Booch, Ivar Jacobson and James Rumbaugh at Rational Software in 1994-1995, with further development led by them through 1996. In 1997, UML was adopted as a standard by the Object Management Group (OMG) and has been managed by this organization ever since. In 2005, UML was also published by the International Organization for Standardization (ISO) as an approved ISO standard, too. Since then, the standard has been periodically revised to cover the latest revision of UML.
So let's check it out. There is the history of UML, and you see there are diagrams. In the final project, you will going to also draw diagrams and prepare UML. You see there is a diagram. Let's open it. You see or here another diagram. These are important. They make explanation much easier. Okay, behavior diagrams, structure diagram, and interaction diagrams, meta modeling, and so on. So, okay, let's continue.
Use cases for the MHC-PMS.
So this is also a UML, and it explains medical receptionist can register patient or view personal info. And then from this personal info, manager can also view it, and manager can also export statistics or generate report. And nurse can view record, edit record. Doctor can also view record and edit record. Doctor can also set up a consultation, and doctor can also generate a report. Actually, there could be arrows in this UML, but they didn't draw it.
Ethnography. A social scientist spends a considerable time observing and analyzing how people actually work. People do not have to explain or articulate their work. Social and organizational factors of importance may be observed. Ethnographic studies have shown that work is usually richer and more complex than suggested by simple system models.
So this is another topic. We are now going to see ethnography. And there is also a description of ethnography. Let's read it.
Ethnography, from Greek ethnos, folk, people, nation, and grapho, I write, is a branch of anthropology and the systematic study of individual cultures. 1. In contrast with ethnology, ethnography explores cultural phenomena from the point of view of the subject of the study. 2. Ethnography is also a type of social research involving the examination of the behavior of the participants in a given social situation and understanding the group members' own interpretation of such behavior. 3. As a form of inquiry, ethnography relies heavily on participant observation, on the researcher participating in the setting or with the people being studied, at least in some marginal role, and seeking to document, in detail, patterns of social interaction and the perspectives of participants, and to understand these in their local contexts. It had its origin in social and cultural anthropology in the early 20th century, but spread to other social science disciplines, notably sociology, during the course of that century. Ethnographers mainly use qualitative methods, though they may also employ quantitative data. The typical ethnography is a holistic study 4-5, and so includes a brief history and an analysis of the terrain, the climate, and the habitat. A wide range of group and organization have been studied by this method, including traditional communities, youth gangs, religious cults, and organizations of various kinds. While, traditionally, ethnography has relied on the physical presence of the researcher in a setting, there is research using the label that has relied on interviews or documents, sometimes to investigate events in the past such as the NASA Challenger disaster. 6. There is also a considerable amount of virtual or online ethnography, sometimes labeled netnography or cyber ethnography.
Okay, so the scope of ethnography, let's check it out.
Requirements that are derived from the way that people actually work rather than the way which process definitions suggest that they ought to work. Requirements that are derived from cooperation and awareness of other people's activities. Awareness of what other people are doing leads to changes in the ways in which we do things. Ethnography is effective for understanding existing processes but cannot identify new features that should be added to a system.
So what is the ethnography's effectiveness? Let's read again.
Ethnography is effective for understanding existing processes but cannot identify new features that should be added to a system.
Okay, so focused ethnography.
Developed in a project studying the air traffic control process. Combines ethnography with prototyping. Prototype development results in unanswered questions which focus the ethnographic analysis. The problem with ethnography is that it studies existing practices which may have some historical basis which is no longer relevant. Ethnography and prototyping for requirements analysis.
So ethnographic analysis, debriefing meetings, focused ethnography from their prototype evaluation and system prototyping, and generic system development from there, and debriefing meetings. So you see it has some iterative process in some stages.
Requirements validation. Concerned with demonstrating that the requirements define the system that the customer really wants. Requirements error costs are high, so validation is very important. Fixing a requirements error after delivery may cost up to 100 times the cost of fixing an implementation error.
You see how important the requirements checking. Okay.
Requirements checking. Validity. Does the system provide the functions which best support the customer's needs? Consistency. Are there any requirements conflicts? Completeness. Are all functions required by the customer included? Realism. Can the requirements be implemented given available budget and technology? Verifiability. Can the requirements be checked?
This is really important. When you are going to take a job, you have to be realistic.
Realism. Can the requirements be implemented given available budget and technology?
And also time frame. Okay, I will add it as well. Okay, let's continue.
Requirements validation techniques. Requirements reviews. Systematic manual analysis of the requirements.
Prototyping,
Using an executable model of the system to check requirements. Covered in Lecture 2.
test case generation.
Developing tests for requirements to check testability.
Okay, requirements reviews. What are they?
Regular reviews should be held while the requirements definition is being formulated. Both client and contractor staff should be involved in reviews. Reviews may be formal, with completed documents, or informal. Good communications between developers, customers, and users can resolve problems at an early stage.
Okay, review checks. Verifiability. Let's make it read.
Verifiability. Is the requirement realistically testable? Comprehensibility. Is the requirement properly understood? Traceability. Is the origin of the requirement clearly stated?
Adaptability.
Can the requirement be changed without a large impact on other requirements?
Okay, so requirements management.
Requirements management. Requirements management is the process of managing changing requirements during the requirements engineering process and system development. New requirements emerge as a system is being developed and after it has gone into use. You need to keep track of individual requirements and maintain links between dependent requirements so that you can assess the impact of requirements changes. You need to establish a formal process for making change proposals and linking these to system requirements. Changing requirements. The business and technical environment of the system always changes after installation. New hardware may be introduced, it may be necessary to interface the system with other systems, business priorities may change with consequent changes in the system support required, and new legislation and regulations may be introduced that the system must necessarily abide by. The people who pay for a system and the users of that system are rarely the same people. System customers impose requirements because of organizational and budgetary constraints. These may conflict with end-user requirements and, after delivery, new features may have to be added for user support if the system is to meet its goals.
I think this is really important. Let's read it again.
The people who pay for a system and the users of that system are rarely the same people.
Which means corporations pays money for that system to be built and it is used by the users, not the corporation itself. Okay, so this is really important to understand. Changing requirements.
Large systems usually have a diverse user community, with many users having different requirements and priorities that may be conflicting or contradictory. The final system requirements are inevitably a compromise between them and, with experience, it is often discovered that the balance of support given to different users has to be changed.
Okay, requirements evaluation, initial understanding of problem, initial requirements, changed understanding of problem, and changed requirements within time, as you can see.
Requirements management planning establishes the level of requirements management detail that is required. Requirements management decisions. Requirements identification. Each requirement must be uniquely identified so that it can be cross-referenced with other requirements. A change management process. This is the set of activities that assess the impact and cost of changes. I discuss this process in more detail in the following section, Traceability Policies. These policies define the relationships between each requirement and between the requirements and the system design that should be recorded. Tool support. Tools that may be used range from specialist requirements management systems to spreadsheets and simple database systems. Requirements change management. Deciding if a requirement's change should be accepted. Problem analysis and change specification. During this stage, the problem or the change proposal is analyzed to check that it is valid. This analysis is fed back to the change requester, who may respond with a more specific requirements change proposal, or decide to withdraw the request. Change analysis and costing. The effect of the proposed change is assessed using traceability information and general knowledge of the system requirements. Once this analysis is completed, a decision is made whether or not to proceed with the requirements change. Change implementation. The requirements document and, where necessary, the system design and implementation are modified. Ideally, the document should be organized so that changes can be easily implemented. Requirements change management.
Identified problem, problem analysis and change specification, change analysis and costing, change implementation, revised requirements. Okay, so you see every area at every stage there are multiple checks. With these checks and proper documentation and proper formalization, you reduce the risks to minimum. You minimize the risks. You prevent mistakes happening, and you are being, let's say, careful at every stage. You are not making unnecessary changes. You are not making uh, extra cost changes that will be resulted in a failure or such. Balance and checks at every stage in software engineering. Okay, you don't just make changes with a hinge. Okay. You carefully plan it, you carefully design it, you carefully analyze it, and you carefully implement it. Okay, key points of the chapter 3 are:
You can use a range of techniques for requirement solicitation, including interviews, scenarios, use cases, and ethnography. Requirements validation is the process of checking the requirements for validity, consistency, completeness, realism, and verifiability. Business, organizational, and technical changes inevitably lead to changes to the requirements for a software system. Requirements management is the process of managing and controlling these changes.
okay, so we have come to end of the lecture. I have purchased a new microphone to improve my voice quality. Hopefully, when it's arrived, my voice will sound better. And we are always looking for volunteers to correct our subtitles. I'm going to upload the slides to our GitHub repository. You will be given a project, and in that project you will be expected to deliver planning and design stages of what we are seeing. Okay, I will post the project details in the future lessons, future weeks. Stay safe, be aware of COVID-19. Okay, let's upload new lectures. You can always contact me and ask me any questions. You know my email, it is on the GitHub page or on our university website. Okay, end of lecture. Hopefully see you next week.